In this video, we are going to talk about function notation. Remember, you are watching, you are listening, and you are going to take notes on your guided notes half sheet. So first, let's just talk about what function notation is. Basically, this part here in the middle, this f of x, is our function notation. When I say notation, what I'm talking about is the way in which we write something. So this is not a change in any of the math that we are doing. It is a change in our notation. So this part right here, this f with the x in parentheses, is the new notation. Now let's kind of talk about what it is and then we'll write some things down. Normally we write y equals. So for this one we would normally write y equals 9x minus 5. Okay? We are going to replace the y with the name of our function, which is f of x in this case. The 9x minus 5 is our defining expression, so it's the expression that determines what the y value is, and the x is our independent variable. So this is a function of x. In other words, it is an expression that has x as the variable, and that this notation tells me that. Okay? Now, the f of x means a couple of things. We're going to write a few things off to the side, and then we're going to actually look at this. So first of all, this is a change in notation. The f of x just replaces the y. And I'm going to take a second here to say it doesn't always have to be f of x. It can be g of x. It can be h of x. It can be a of x. But typically the three we use the most often: f of x, g of x, h of x. So again, just replaces the y. What it means is that it is a function with x as the variable. And the way that we say it is f of x. So it is read as f of x. And again, it just means I've got a function that has x as a variable. We've already talked about what a function means. It's a relation where each member of the domain is mapped to a unique member of the range. In other words, the x's do not get reused. Okay, last little note, and then we're actually going to take a look at this, and it's very easy. Looks complicated, but it's very easy. The last little note, I know normally when we see these parentheses, we think multiplication. This is not multiplication. This is a function notation. So this is not f times x. It's f of x. And I'm going to show you how we use it in some examples. Okay, so here we go. First, let's kind of talk about this equation in two variables. All that means is that my equation, instead of being something like, you don't have to write this down, x plus 3 equals 10, where I have just one variable, I have two variables. So if you look at the example here, and I do want you to write this down, if you look at the example here, y equals 3x minus 2. I've got an x and a y. Okay, so that is an equation in two variables. Now I'm going to take that same equation and I'm going to change it to function notation. All I'm going to do is replace the y with f of x. So again, this is now read f of x equals 3x minus 2. 3 times x minus 2. All right, here is why we do this. This function notation here with the f of x is a little more powerful than our notation with just a y. We can do more with it. What f of 3, notice how I said that, f of 3, what that means is to evaluate the value of y when x equals 3. In other words, this notation here, this f of 3, tells me to go into my function, take out the x, and put in a 3. See that? So let's make sure we understand what happened there. This is my f of x. It's a function with x as the variable. When I ask for f of 3, I take out the x and I plug in 3. That's it. Now I can evaluate. So 9 minus 2, which is 7. Okay, so if I'm asked to evaluate, f of 3 equals 7. What this means is when x is 3, y is 7. That's what it means. So f of 3 equals 7 tells me both the x value and the y value. Okay, let's look at a couple more examples. We're going to go simple first. We're going to just do some more evaluating. Okay, I was just making sure I was still recording because I didn't see my recording symbol there. All right, so here we go. I am going to, example 1, given f of x equals 1/2 x plus 8, find f of 4. So remember what that means. I am going to find the x, I'm going to take out the x, and I'm going to plug in -4. And I know there's a fraction, and I know that kind of freaks some of you out, but it's not bad. Watch. So I'm going to go here. Everywhere I see an x, I'm going to take it out, and I'm going to put in a -4. Okay? And then I'm going to evaluate. So 1/2 times -4. Guys, multiplying by 1/2 is the same as dividing by 2. So this is 4 over 2, which is 2. Signs are different, so it's going to be negative. And then -2 plus 8. Signs are different, so I'm going to subtract and keep the sign of the larger. So f of -4 equals 6. Again, that tells me two things. It tells me when x is -4, y is 6. That's your answer right there, though. This is just me clarifying the meaning. Okay, example 2. Again, given f of x equals 2x squared minus 3, find f of 5. I am going to go into my function, and everywhere I see an x, replace it with a 5. F of 5 means 2, take out the x, plug in 5. So 2 times 5 squared minus 3. Don't forget your order of operations as I evaluate here. I'm going to first do my exponent. Then I'm going to do my multiplication. Be careful there. Some of you probably tried to multiply before you squared. You need to square before you multiply. Okay, and then subtracting. So again, f of 5 equals 47. So x is 5, y is 47. We can also use this to graph, this function notation, and we'll be using it quite a bit to graph this year. So we're going to do example 3, which is going to require us to do that. If you need to pause here, go ahead and do so. I'm going to continue on to example 3. Example 3, the cost of x gallons of heating oil can be represented by the function f of x equals 4x plus 6. And we want to graph the function. Now the way we are going to do that is just by completing a table of values and then plotting those points. So let's start by drawing our table of values. We're going to do x. We're going to do f of x equals 4x plus 6. And that's going to give us our ordered pairs. Or our points. Probably would have been easier to write points. Now, I am going to choose values for x just kind of randomly. Ones that are easy to plug in, that will give us a nice graph. You don't have to use the same values as me, except in this video, but when you're doing problems on your own, you can choose different values. So I'm going to go -2, -1, 0, 1, 2. I'm doing 5 points, which is probably a little more than I need, but I want to make sure we understand this function notation. So again, I chose those values of x because I know that they'll give me a good graph. You can always use those values of x, particularly with your linear functions. All right, here we go. F of negative 2. So I'm going to take out the x and plug in negative 2, which is going to give me negative 8 plus 6, which is negative 2. Signs are different, so I subtract and keep the sign of the larger. So for this first one, my ordered pair, the x was negative 2, the y is negative 2. Let's do negative 1. F of negative 1. I'm going to take out the x. I'm going to plug in negative 1. So 4 times negative 1 is negative 4 plus 6, which is 2. So that gives me the ordered pair. X is negative 1, y is 2. Plugging in 0. F of 0. 4 times 0 plus 6. I'm just replacing the x with 0. 0 plus 6, which is 6. The ordered pair there, x is 0, y is 6. Continuing on, x is 1. F of 1. I'm going to take out the x, plug in 1. So I get 4 times 1 is 4, plus 6 is 10. So that's the ordered pair 1, 10. And I can see 2 is going to be so big, it's going to be off my graph, but I'll still plug it in. F of 2 is 4 times 2 plus 6, which is 8 plus 6, which is 14. That gives me the point 2, 14. Okay, I did all that kind of quickly, but as you can see, all I did each time, I took out the x and replaced it with the corresponding value that I chose for my x's here. The last thing I need to do is plot those points. So I'm going to use this last column where I wrote my ordered pairs. So negative 2, negative 2. So I'm going to go left 2, down 2. That's going to be right there. Negative 1, 2. Negative 1, positive 2. 0, 6. That's going to go a little off my grid. I'm going to do a little guessing. And the rest of them are so big, they're going to go off my grid. So I'm going to go ahead and connect in a nice straight line. I knew this was going to be a straight line. I'll tell you how later. Connect in a nice straight line. Do a better job than me. Connect and extend through. So this is how I would use my function notation to graph a linear function, a function whose graph is a line. All right, we're going to do some more practice with this in class. Right now you're going to glue this half sheet into your interactive notebook and get ready for the next thing.